From Unit 2 onwards, we'll be coming across a lot of equations that we need to be able to solve. Now, solving equations is one of the most difficult things that you're going to learn in this course, but it's also one of the most valuable things. Now, an equation, in case you're not sure what that is, it's whenever you have two mathematical expressions that have an equal sign somewhere in the expression. So let's say we had something like x plus 2 is equal to 10. This x is called a variable. It's a placeholder. You could think of it like a blank spot. This is an equation. And if we quickly analyze this equation, it's saying that some number is being added to 2. And when you add 2 to that number, we end up getting a 10. A lot of students get stuck on this concept because they think they can just guess. They can guess what number goes in there. Now, yeah, you can do that for some problems, but if you rely on that too much, you will be getting stuck pretty quickly. So what plus 2 gives me 10? That number would have to be an 8, right? But instead of just guessing those answers, there is a proper way to do it. And that's what this video is going to go over, is how do I actually solve for this variable? How do I get that x by itself? So before I can explain anything, there are a couple of things that I want to point out. And that is the idea of opposite mathematical operations. In other words, adding, if you add a number to a value, it's the opposite of subtracting a number from it, right? So addition and subtracting are opposites, and that's one of the key things that you need to know to solve equations. The other thing is multiplying and dividing. Those two operations are considered opposites. The opposite of multiplying a number is dividing a number. So those are two key things worth noting. And the last thing right here, or second to last thing, is whatever you do to one side of the equation, you must do to the other. And we also don't want to guess answers like I already went over. So let me address this third option before I get into the other explanations. We look at this example that I wrote up here. This equal sign separates the equation into two parts. What we can consider to be the left side and what we would consider to be the right side. Okay, so this is the left side, and on the other side this would be the right side. So it doesn't matter what we end up doing to this left side. If we do anything to the left side, if we add a number to it, if we subtract a number to it, we need to do the exact same thing to the right side. We don't change the signs of anything. So if I do go over this example, the way you always start off these problems is by reading the expression in your head. You would read x plus 2 equals 10. Now our goal is to eventually get an answer where x is by itself. But to reach that goal, you need to understand what's happening. If I were to ask you what is happening to this x value, what would you tell me? X is being what? In this case, x is being added to 2. So if x is being added to 2 and we want to get the x alone, if we want to get the x by itself, we simply need to do the opposite of adding 2. The opposite of addition is subtraction, so we're actually going to subtract 2 from the left side. So I'm going to write this right below the 2. Instead of adding 2, I'm going to write a minus 2. Now, because I did this to the left-hand side of the equation, I need to do the exact same thing to the right-hand side, and I end up getting this expression of 10 minus 2. Now, if I simplify this entire equation, if we do the math, this is 2 minus 2. 2 minus 2 gives me a 0, which we don't need to write down. So instead, we just ignore them. We actually just cross them out like this. But what are we left with on the left side? We're left with an x, so we copy that x down. We have an equal sign, and then on the right hand side we have 10 minus 2, and 10 minus 2 is our final answer of 8. So in the end we get this expression that says that my x value, that letter, is really represented by the 8. This 8 that we found is called a solution to the equation. If the x is an 8, then it solves this expression. It becomes a true statement because 8 plus 2 does, in fact, give us 10. So this would be the answer to the equation. And that thought process we're going to apply to every single problem that we come across. Okay, so if we look at these examples, these are all pretty basic. They're one-step problems, but if you do not know how to do this, then you will get stuck in this class and you'll struggle a lot. If we look at this first problem, our goal is to get x by itself. So the first step in any of these problems is to figure out what is happening to that x. Now the x is on the left-hand side of the equation, right? It's right here somewhere. So ignore the other side. The other side doesn't matter. It doesn't matter what's over there. What's going on to this x value? X is being subtracted, right? It's being subtracted by 4. So if we're trying to get x by itself, we're going to undo that subtraction. We're going to do the opposite of subtracting 4. Opposite of subtracting 4 is adding 4. So I want to put a plus 4 at the bottom of this minus 4. On the other side of the equation though, right, what we do to the left side, we do to the right side. So I'm going to write a plus 4 on the right side too. Now it's a matter of simplifying the expression. On the left side, the negative 4 plus 4, those always cancel out because they're opposites, and we're always going to do the opposite. So they're always going to cancel out, and it'll leave me with an x. Now on the right hand side, we have 12 plus 4 now, and 12 plus 4, 16. So we're done with this problem because the x is by itself. For the next problem, I'm going to work this out. We have x plus 8, and that's equal to 8. To get the x by itself, we look at what's happening. X is being added to 8, so we are going to subtract 8. And what we do to one side, we do to the other. So I put a minus 8 on the right side. On the left-hand side, 8 minus 8, they give me a 0. We can just cancel them out. And it leaves me with an x. We have this equal sign, so we just copy down the equal sign. And on the right-hand side, we end up getting 8 minus 8, which also goes away. But in this case, we don't really want to, we can cross them out, but we don't want to leave this blank. Notice how the right side of the x, it always needs to have some number. So what is 8 minus 8? 8 minus 8 is really a 0. So we could ignore the 0 on the left-hand side, but on the right-hand side, we need to have a number. So in this case, it would be 0. Moving on to the next problems, we're going to apply the same thought process to solve them. So in this case, we have x plus 5 equals negative 6. So that we don't get confused, you can ignore the right-hand side. Just focus on the left. What's happening to this x value? It's being added to 5. What's the opposite of adding 5? It's subtracting 5. So we're actually going to subtract 5 from both sides. Now, if we simplify it, on the left-hand side, 5 minus 5, positive 5 minus 5 gives a 0. So we're left with an x. We have an equal sign, so we bring that down. But on the right-hand side, this is where the integers come into play. So negative 6 minus 5, you need to be able to do that without any major issues. Negative 6 minus 5 ends up giving me negative 11. And if you're not sure on why it's negative 11, I would recommend looking at the video that I have over working with integers. But because they're both negative, we add the numbers together, so we get an 11. And the larger of the two numbers is a 6, so we get a negative from that 6. We get negative 11 as an answer. All right, so moving on to the next one, x plus 2 equals 10. I want to get the x by itself, so I'm going to do the opposite of whatever's happening to it. X is being added to 2, so I'm going to subtract 2. And what I do to one side of the equation, the left side, I do to the right side, so I'm going to subtract 2 from the other side as well. This will leave me with x equals whatever 10 minus 2 is, which is 8, and that would be my final answer. Now these last few examples go over multiplication and division, but the idea is the same. On the left-hand side, it looks like a fraction. Well, it is a fraction, but you can think of it as division as well. This is x divided by 4 equals 10. So what's going on with the x value? The x is being divided by 4. What's the opposite of dividing by 4? It's multiplying by 4. So I'm actually going to take the left-hand side and I'm going to write times 4. Now you can write it a little bit closer to the fraction like this, times 4, but it just looks a little messy. So I usually write it off to the left-hand side, times 4. And on the right part of the equation, because we're multiplying the left side by 4, I'm going to need to multiply the right side by 4 as well. Now on the left hand side, we might not be too comfortable with multiplying whole numbers with fractions, but when you multiply 4 times what you could think of as 1 over 4, 4 times 1 over 4, the 4's end up canceling out. And in case that's confusing, just think about the idea that right now x is being divided. So if we do the opposite, if we multiply it, then those 4's just end up canceling out. So the 4's go away, and it leaves us with an x. On the right hand side, we get 10 times 4, which is just 40. And this will be my final answer. Now the way I show my work when dividing is by making a fraction. So x is being multiplied by 3, so we're going to divide this side by 3. What I did to the left side, I did to the right side. So on the right hand side, I'm going to make another division, or another fraction, and put a 3 at the bottom. On the left hand side, 3 divided by 3, it does give me a 1. So this expression would leave me with 1 times x, but that's just x. So we can actually just cross out the 3's, similar to any of the other problems we've done. Because the opposite of multiplying by 3 is dividing by 3, we write it out and we just cross them out. That leaves me with x equals whatever 12 divided by 3 is. And 12 divided by 3 is 4, which would be my final answer. 2 more problems. So right here we have 5x equals 30. Now this is a new situation where we don't have a sign. So if you think about what's happening to x, it might be a little confusing. There's no symbol, there's no plus, minus, multiply, or divide. But anytime there's a whole number next to a variable, like it is in this problem, there's a number next to a letter, that means that they're being multiplied. So this is actually 5 times x equals 30. So if we ask ourselves what's going on with x, the x is being multiplied by 5. So what's the opposite of that? The opposite of multiplying by 5 is dividing by 5. So we actually take both sides and we divide each of the sides by 5. On the left hand side, the 5's are going to cross out and it'll leave me with x. On the right hand side, we get 30 divided by 5, which ends up giving me 6. And 6 is the final answer. For the last problem, it's the same idea as the rest of them. It's just written down a little differently. What's happening to x? X is being divided by 4. So instead of dividing by 4, we are going to multiply by 4. Now this one, the way you show your work's a little confusing. You can either write a times 4 off to the side like this, or you can write times 4 like this. But it is a little confusing because this looks like it would be 4 times 4, which would be 16, but no. One of them is a division by 4, one of them is multiplication by 4. So they're actually going to cancel out. But if we multiply the left side by 4, we need to multiply the right side by 4 as well. So on the left hand side, they cancel out because they're opposites. And on the right hand side, we're left with 20 times 4, which is 80. If you understand these fundamental examples, adding, subtracting, multiplying, and dividing with x's, then we can move on to the more complicated problems. And in this class, you'll have a lot of those complicated ones. Doesn't mean it takes a long time, but it just takes quite a bit of concentration to solve those problems. So for the second half of this video, that's what I'll do.